we'll go ahead and get started now. Quiet, please. Jimmy, any questions on the homework you did for today?
Nope.
You got done?
He says that like a surprise.
Any questions on this one? Any questions through here? Fantastic. Oh, Sydney?
Yeah, on number 17, actually, how do you know what numbers are?
Just graph them out and see where it crosses the x-axis. All right?
I like this section. Let's
Only
not
the thing about like the constant, like you know, based on the constant, you know, it's like what the general number is, I guess.
Yeah.
What was that?
No,
That's for polynomials. For polynomials, you can look at the factors. Okay? All right. Let's see. In the notes, I got 3 more questions to go through, I believe. We did that one. We did this one, didn't we?
No.
Okay. Okay. Go ahead and let her back in. Good.
Password.
Wow.
Password. She said taco.
All right. Perfect. All right. Here we go. Now, this one, when it says approximate to 2 decimal places the x-coordinates, this one has 2 equations. You need 3 equations. There are 2 ways you can do this. Oh, it's really 24? Thanks. 2 ways you can do this. I'm going to make it into 1 equation. And when I make it into 1 equation, it'll look like a function of x. Sine of 2x. Now, when you're solving this, it says find the points of intersection. Well, you take sine of 2x, say equals 6x minus 6. When you do that, I'm going to write it as 1 equation because I'm going to subtract 6x minus 6. Now, I'm using Newton's method because I'm looking for the zeros of a polynomial. The other way to do it is to graph it on your calculator and find the intersection points. But we're using Newton's method for approximation. That leaves us only 1 way of doing it. So, I'm going to graph it out like this. And again, the hardest thing you're going to have to do is, I'm going to use Newton's method to approximate the zeros. You have to come up with an approximation, and you also have to come up with a derivative, and the chain rule some people are still struggling with. The derivative, let's see, what would be the derivative of sine of 2x? Mark. Very good. 2 cosine of 2x would be the derivative, and then you subtract 6, because negative 6x, the derivative is negative 6. So there's my function, and there's my derivative. Now, I would not put both of these in right away. Yeah, I'd put the first one in, see where it goes through at, and then I use that as my guess. If you notice, the interesting thing about this is, let's see, sine of 2x, again making sure you're in radians, minus, parentheses, 6x minus 6. And I'll just go to the regular window of 0 to 10, or negative 10 to 10. And with trig functions, you really don't know how many answers you're going to get right away until you look. Probably, I'm guessing 1. There's 1 answer. That looks like it's close to 1. So you have to come up with some idea before you start. So my guess is going to be 1. And what we're doing on here is make sure they know I'm recording this for Shane. No password. I'm recording. Quiet. Thank you. And go to y sub 2. And when you put that in, that would just be the derivative. 2 cosine.
The 0 is really 1.12. Does it matter if we use the decimal or the...
No, just 1's fine. Yep. 2 cosine 2x. This will be minus 6. Quiet, please. Quiet, please. You're losing focus of what's important here, which is mean. All right. So now I have this, second and quit. And the nice thing about this is that when I put 1 in as my guess, usually, I don't know how many of you have scrolled back very far, but you can scroll back quite a ways. I'm going to see if I can go back to yesterday. 1, enter. I want to see if I can scroll back and capture yesterday, even though I've been doing this all day on the calculator. I just want to see if I can capture it. Some people don't even bother doing this. I think it's kind of fun. See what you've been up to. Oh, there's 3rd hour, 2nd hour, 1st hour, 7th hour yesterday.
Oh,
Just short. Oh well, so be it. I'll just second answer, minus, vars, y vars, function, y1, parentheses, second answer, divided by, oh, I don't need this. Usually, I think it said 4. Vars, y vars, function, y2, second answer, and then we'll close it off. And you can see right away I get to 4 decimal places pretty quick. Now, again, I am the one that told you in the first place you could use calculate 0 to find this on the graph. I showed you all that last year. I've showed you the math solver on here, which you have a seed you can put the number in. This is one of the applications of calculus that makes all that possible. That's why I want you to make sure you told me what the guess is, show me your equations, and show me when you reach the 4 decimal place of accuracy. It's important that you write that down, because if you don't, obviously I'll think you did one of the other ways of doing it.
Please excuse the interruption. Would all Marine platoon leaders report to the small gym for pictures?
Nice. So I want you to use Newton's method and calculus to solve this. There's a lot more applications of calculus. Okay? So, I think we're about done, actually. And, was there one more? Oh, here we go. Is this in your homework, number what? It is number 30? Oh. It's on your homework at all? 28? Perfect. So, if f of x equals x to the 1/3, show that Newton's method fails for the first approximation of your first guess can't equal 0. Why can't you guess x equals 0? Mark? Right, you'd have something undefined. Hi. Okay. All right. What did you say, Mark? If you put 0 in what? Well, actually, you don't even have to go that far, because the derivative value is going to be undefined to begin with. You have a number to a negative exponent, so it's going to be undefined. Okay? So that's pretty good. Excuse me. All right. And I think the last one is this one.
Can you go back to the? No. I didn't get anything.
0 is 0.
Go back to 0 to 0 1. Undefined.
Yeah. All right, and the last one. All right? So, here we go. Last one. We're going to do number 30. Your last one for homework will be 29. Ready? The functions f and g have a 0 at x equals 1. That's interesting. Let x sub 1 equal 1.1 and find the iterations for each function. Why are the approximations from 0 of g more accurate than those from 0 of f? Any idea? Yes, Suzanne? and it's undefined. Right, that's showing that it doesn't work. On this one, so this is telling you let your guess be 1.1, and when you put it in, it works out. Let x be defined for each function. So for f, I don't know. Oh, this is using the product rule. Nice. And G is using the product rule.
You do for both of them?
Yeah, we'll just do it for one of them. We'll do it for the f function first. Do you remember what the derivative is of the product? Ben, how do you take the derivative? Right, so it'd be 2 times x minus 1. Square root of x plus 7, good. X minus 1. 1/2 x plus 7 to negative 1/2. Good.
Yeah.
X minus 1 squared right here. Perfect. All right, so that's the derivative. It says that 1, well, yeah, you can see 1's going to be a root of that. You put in 1, you're going to get out 0. Find 1, 2, 3, 4. All right, so I got to find 4 answers for this one. I think I'm going to try this just for fun since this one's a little complex. I'm going to go to y equals, and this is the last time I'm changing this. Ready? X minus 1. X minus 1 squared times the square root, second square root of x plus 7. And you see how this is kind of a lot to write right here? I mean, that derivative is pretty long, isn't it? I think I'm going to try this. I want to see if it works. I'm going to go to math, in derivative, and then I'm going to put in bars, y bars, function, y1, comma, x, comma, x. And that should give me all the numerical derivative values of the equation. So it's like typing in the derivative. Yes?
I think I have to type in the 2 x's. What are those for again?
1 stands for the variable of your equation, and the last one stands for the value you're putting in to the equation. Okay, since I'm using a lot of x values, and I want to see if this works. So I'm going to go back to the home screen, second quit. Excuse me?
It's right here.
Oh.
What did you have in the y1 for an
I had the original equation for f, x minus 1 squared and square root of x plus 7. Okay, so I'm going to type in 1.1, press enter, second, enter, second, and enter. And like I said, I'm going to hope this works. Math. All right, so there's 1.05, 1.025, 1.012. It only wants those 3, so that's pretty nifty. Now we've taken it from the first day, we had a very long, convoluted junk on the home screen. And we changed it on day 2, so now we had our equations in y1 and y2 because they weren't very difficult. Now on this day, the equations you can see are getting obviously a lot more involved. So that's why we've changed it again to match the situation. That's what you do, is you try to come up with another approach to handle something that's a little bit more complicated so you remain efficient at it instead of getting bogged down. So those would be the 3 answers for that one. Why are approximations of the 0 for G accurate and no 0 for F? I don't know. I think we can do G real fast, don't you?
Yeah, you do both separately, you just do F separately, then you do.
Yeah, I wanted to show how I was going to approach F first. So now with that approach, you'll see that G isn't that difficult. So I'm going to type in for G, I'm going to take away, isn't it just this x squared?
Yeah.
Technology, I say this every summer when I talked to some people about this. Second and enter, second and enter. And you notice it gets there a lot faster. Okay? So now, we've compared the two, and one is getting there a lot faster than the other one. Why do you think that is? And this is a, yes, Suzanne? Correct, it was the function g. Okay, I just put g in. Why do you think this one on the right, yeah?
How do you know the guess one put in?
The direction said, it said let the first value be 1.1, then find these three. It told you the answer was 1 because it knew ahead of time this one's going to get to 1 really quick. What's the difference between the two? Why is one getting there faster than the other one? If you look at the equations you started with.
There's no square.
There's no squares, so what kind of function is it? It's linear. So it's going to travel a lot easier the tangent lines. On a quadratic, you might have to go all the way around before you actually get to the answer. On a linear graph, you're just going to follow it right to the answer, and it's going to be pretty quick. The tangent line is the same as linear graph. Yep.
By using, like, what are they finding again, by doing this?
Oh, you're finding the zeros of the polynomial? Approximating the zeros. Okay? So we found one of f, we found one of g, and then we compared the two as to why one got there faster than the other one. Okay? Yes?
For that y2 equation with using like just the derivative,
Right.
can you just leave that there? Like,
Sure. That's fine.
Because I'm using that another problem.
Yeah. Sure. So, now, don't misunderstand. On your test, now I haven't brought up the practice test yet, but on your test, if it says, write the equation for Newton's method, you can't write answer minus function of answer over inderivative of answer. Okay, you'd actually have, the equations, the 1.1 minus the x plus 1, squared, square root of x plus 7, all over that long derivative. You'd actually have all those derivatives and the way it's written in your answer, okay? The inderivative or the y1, y2 or the function notation, those are just ways of using your calculator so you can use Newton's method a little quicker than getting bogged down in the work and the typing it in. Yes?
So then the x3 and x4, is that just how many times you press enter?
Correct.
Okay.
It wanted you to be able to make sure that you saw that one got to 0 a lot fast, or one got to 1 a lot faster than the other one.
Okay.
So one of these three values is their answer. Okay? All right. Anything else?
That's just equal to so what? Like when you do the 1.1 it's like Newton's method. What's that?
Oh, that's just this. That actually equals, no, it equals x sub 2.
Oh.
So when you do all this, 1.1 minus the function value of 1.1 or the derivative of 1.1
It equals this.
actually equals x sub 2, your next guess. And then that goes in. Yes?
So on our test, what would we have to write?
Well, you have to list out the function and the derivative.
Do we have to, so when we write it out and then use our...
Right. That's fine. But I want to make sure that, people aren't doing like the calculator screen as an answer to the question when it's asking for the algebra. It's asking, what does it look like?
Will it be clear when...
Sure. It should be. I would think so. Anyway, I'm going to take a look at that. As a side note, I'm going to say this now because I don't know what's going to happen in, well, I know some people are leaving, is it Friday? Or a week from Friday? Is it this Friday? Okay. All right. Now, I want to bring this to whoever's attention. I'm doing it now on the recording, so Shane's aware of it. Oh, I don't want the calculator. I want this.
Calculator's right there.
I want the internet. Here is the plans. These plans do not change based on weather, okay? I'm speaking because the trend on my tweets right now is all about the weather. Well, there's other things. Apparently the storm's getting bigger than what they anticipated in the beginning. Anyway,
When? When are they supposed to
this weekend. So, quiet please. Here we go. This is what's important. I realize everybody's getting all excited. Oh. I have, today is Wednesday. I'm going to put this right here on this link. Okay? Quiet please. Listen. This doesn't change. I'm going to start, we're going to start reviewing for our test, which is going to be on Tuesday. One of these, I mean, you'll have a 5 for 10 over Newton's method, or maybe even some problems due for Newton's method. But your exam is scheduled for Tuesday and Wednesday. All right? Even if you lose the review on Monday, the exam is still on Tuesday and Wednesday. Okay? Yes.
We will have next week then, right? And then we're done.
Well, yeah, I'm getting to that. Now listen. On these links right here, Thursday and Friday, I'm going to put up, between both of these, 3 fall final review packets. Okay? And this class isn't scheduled to take the final until Wednesday. If you're somebody that doesn't have to take it, but you want to try to work something in, I'll work with you. But the review packets will be posted probably tomorrow. I'm going to go ahead and I convert them to PDFs. I'm going to send them up. Okay?
Will we work on those Monday?
Yes. Monday they'll be working on, and Thursday and Friday and Monday. The reason I'm giving 3 days, there are 3 packets, 15 questions each, I believe. It takes a while to get through them. The final itself is only 20 questions, but you'll see what I mean by the 15 questions, how long they are, and they go all the way back to limits.
So the people that aren't taking finals are just doing it for a grade, they're not,
Well, yeah, they'll turn in as just a regular worksheet.
and how much points is
Yeah. Oh, each one will be probably worth 10 points. That'll be 30 points. Okay? So if you're not planning on being here on that Monday, that's fine. You can get them way ahead. Okay? I'm going to post those early, and
print them out?
Should I do them before I go, or?
that's up to you. I don't know how much time you're going to need. Yes.
How many points is that?
This exam?
Yeah.
Oh, I don't know. How many questions do you think?
How many
I'm thinking 25 questions.
Oh, I thought it was 10.
So anyway. Oh, let me give you the assignment first. I'm running out of time.
So like 100 points?
It won't be 100. I couldn't do that to you guys. It'd be more like, probably like 80, I'm thinking.
No.
Let's see, 23 through 29 odd. What page? Page 234. Okay? You'll probably have a 5 for 10 or 10 for 10 on this section either tomorrow or Friday. Okay? All right, Shane, hope you got all that.